Good day mga kamatiks! Kamusta kayong lahat dyan? Dito naman tayo sa bagong video tutorial natin. Ang content ay extracting the root. So hindi lang square root, hindi lang cube root, but also it could be any root. Okay? So let's start. Okay, so first we need to get familiarized with the laws of radicals. So these laws are the laws that we're going to use when we simplify radicals. But for today, since we're going to talk about extracting the root only, so we're going to use specifically 1 and 3, alright? So take note of those laws also. Okay, so when we simplify radicals, let's have first this one. Suppose an expression with an index of the radical is n. Express its radicand into perfect power, nth power, and extract the nth root of the radicand since the radicand is a perfect nth power. So what does it mean? My brain is freezing. Okay, so if you put it into symbol, you can have it this way. Alright, so the index is n, and then the radicand, okay, so it's on perfect power n, and you can it is equal to radicand a. Okay, what happened to the exponent and the index, the power and the root n? So it is cancelled, alright? Okay, which means that the nth root of a number a raised to n is equal to the number a. Okay, so let's put this into illustrative example. Right? So let's have cube root of 125. So if you put 125 into perfect power, right? So it's 5 cubed, right? So the root here is n, or the index is 3, and then the power here is 3. So what happens is you're just going to cancel them out. So your answer is 5. But you might be wondering, how did we get 5 to the power of 1? Okay, so for you to really understand what's happening here, let's put this part of the solution as rational exponent. You still remember the rational exponent, right? So basically 5, this is our power and this is our root, right? So the power over the root. So it's 5 over the power 3, and then the root over the root, which is 3 also. So if you divide this 2, 3 over 3, basically you will come up with 5 to the power of 1, which is equal to 5, right? So there's no need for us to write 1 anymore. Then let's have this example. Another example. Square root of 36x squared. Okay? So first you need to express the number into perfect n powers, right? So ano nga ba yung perfect n power ng 36? So if you still remember, you can express 36 as what? Right, 6 squared. And copy the rest, x squared. Then third, what is the index here? You can't see it. So if it's 2, there's no need for us to write 2, right? So therefore, your answer is 6x. What happened? It is cancelled. So if you put the solution here in this form, it's 1, you can have it 6 to the power of 2 over 2, the power over the root, right? Then x to the power of 2 over 2 also, which is 6 to the power of 1, x to the power of 1, and then in simplified form you will come up with 6x, right? So again, there's no need for us to write 1 as exponent. So if there's nothing written there, it's understood as there is 1 in the exponent. Okay, so these following examples are just the same, contains the same process with the previous examples that I gave you. So what happens is you're just going to cancel the radical sign and the exponent. So you have 16. You cancel. You have 21. Cancel. You have 3x minus 4. Cancel. You have 3x over y. Cancel. You have 3x minus 4. Cancel. The 7 and the 7 to 8 minus 4y. Alright, so if you notice the exponent here and this one is in the inside of the radicand or in the radicand. This one is outside the radicand. So basically, if you put this 7 inside the radicand or in the radicand, it's just the same, right? You can cancel it. Okay, so there are also times that a given expression cannot be just easily cancelled. You just have to divide it first before you can get the answer. Alright, so what I mean is this one. 3 square root of 4b 8, b raised to 8. So first you need to express 4 as what? First, perfect n powers. Or perfect n power, right? So what could be the possible n power, perfect n power of 4? So it's 2 squared, right? So you just have to put it into rational exponent, then you divide. Again, where did we get this? The power over the root here. Power over the root here, right? So 2 over 2, 8 over 2, right? So and then 2 to the power of 1, b to the power of 4. You're not done yet. Since you have to multiply this one, you will come up with 6b raised to 4. Now, sir, is it necessary to follow this part of the solution? Now, my advice is if you know, if you're familiar, if you're master with the process, you don't have to. Okay, you don't have to. What I mean is if you can take it just by looking at the expression. So here, 2 divided by the root here, or the index 2, you can have 1 to the power of 1, and 8 divided by 2, you can have it 4, b to the power of 4, right? So there's no need for you to really do this part of the solution. But if in case you really need a visual part of that solution, why is it that it is 2 to the power of 1 and b to the power of 4? It's okay also if you write it, right? Now, let's proceed to the next example. 2x square root of 16x raised to 4 y 4. Okay, so there, again, I said it earlier, there are times that the radicand is in perfect power, but the index and the exponent are not the same. And what I mean is the power of the radicand are not the same, so you just have to divide it. Alright, so 16 can be expressed as a perfect power 4 square, right? So now if you don't, if you're really master with the solution, you just have to divide the 2 by the index 2, and the 6 by the index 2, and the 4 by the index 2. So this one. Okay, so 2 divided by 2, 6 over 2, 4 over 2. Then next is simplify. 4 to the power of 1, x to the power of 3, y to the power of 2. So the solution is not done yet since you still have an external part of the expression of the parentheses. So you just have to multiply. Okay, so 2 times 4, so and then x times x. So when you multiply this part, in this part, you need to follow the law of exponents, remember? So the multiplying powers, so 2 times 4, it's 8. And then x times x cubed, still remember the multiplying powers, you have to add the exponent. So it's 8x4 y squared. Okay. Next example, negative 2y 4 cube root of negative 8x9 y12. So take note of the sign here, it's cube root. So sir, is there a root? Okay, so since the index is odd, okay, and then the number here is negative, we can get a root out of that. Okay, so we can express negative 8. What should be the base of the perfect n power? So the base is negative 2. You can check it if you like. Negative 2 times negative 2 times negative 2 is equal to negative 8. Then raise to the power of 3, x to the power of 9, y to the power of 12. And then you just have to copy whatever is in the outside of the radical. And then you can now express them as a rational exponent, or you can proceed to division of this one, the powers inside the radical or the radical. So 3 divided by 3 is 1, 9 divided by 3, that's 3, 12 divided by 3, that's 4. So what I mean is this form, alright? 3 divided by 3, 9 over 3, 12 divided by 3. And then you just have to copy this part. And then you can now simplify negative 2. You can now get the simplified form, negative 2 to the power of 1, and x cubed y4. Then you just have to multiply. So negative times negative, it's positive 4, and then x, copy the x cubed, and then y4 plus 4 is y8. Right? So last 2 examples. Now there are times that you can use this law, right? Apply this law when you encounter fractions. Okay? The radical is in fractional form. So first you have to simplify whatever the number is. So 625 divided by 5, it's 125. So the quotient must be in the numerator. And then you have to follow the quotient law of exponent. You subtract the exponent, 7 minus 1, still remember? Okay. So there's an error here. It should be 6 here, right? And then here it's 6. And then 5 cubed, it came from 125. You express 125 as perfect n power of 3, okay? And then x6 y cubed. Then you have to put them in this form, right? And then you can put them into rational exponent, 3 over 3, 6 over 3, or maybe you can divide it already. 3 over 3, 6 divided by 3. So the answer is 5. So since 3 over 3 and then 6 over 3 is x squared and y. Alright? Then let's proceed to the last example. Okay, so this one will take maybe a minute. Okay, the same principle, the first law and then the third law. Okay, so fourth root of quantity 4a9b over 64a5b negative 11 to the power of 2. So first you simplify the radical. So 4 over 64, that's over 16 na lang. And then a to the power of 9 over a to the power of 5, that's a4. And b, so you follow the quotient law, right? So next is quotient law of exponent. Division law of exponent here, the b. And here, quotient law of exponent, you multiply the exponent outside. So 4 times 2, 12 times 2, 4 times 2. And you get 4th root of a8, b24, 2 to the power of 8. Then you divide the exponent. Okay, so 8 over 4 to the 4 over 4, 8 over 4. Then you come up with the final answer of a squared b6. Now, if you want to practice, you can have these following items. Thanks for watching.